All right, so in this problem right here, we have an original perimeter. So this is the original. Okay? It tells us the width of the new one is going to be doubled. The length of the new one is going to be increased by 5. And that the new perimeter, this will be a new one, is going to be 66. And the question says, what was the length of the original? Okay? Now, do you know what perimeter is? What's the definition of perimeter? Okay, so it's the length or the distance around an object, right? The length of the distance around an object. Now, you don't have to know the formula, but I do know that in a rectangle I got a length and a length that are the same thing. You agree? And I know that the width and the width are the same thing. You agree? And so if I wanted to find the perimeter, then what I would do is I would take this length plus this width plus this width, and I would get the value. We all agree?
So L2 plus W.
Right. And so the actual formula is that right there. You don't have to know that formula to be able to work the problem. I could do this and then put it together with like terms. Okay? And so what we have here is we have a length and a width, and from the original one we have 46 equals 2L plus 2W. And every one of you in here, given the proper amount of time and developing the proper amount of desire, you could probably plug numbers in and figure out, since the length has to be the same and the width has to be the same, what those values need to be to generate a perimeter of 46. You could do that. That wouldn't get you the wrong answer, because the question says what's the original length. Okay? However, if you're going to use this as the system of equations, you now have another perimeter that's been calculated that is at 66. And what are the effects that change to get it up to 66? All right, the perimeter is going to increase by 20, so the things have to change. And what changed was the width changed and the length changed. All right, so what changed in the length? What does it say it changed in the length?
5.
It increases by 5 meters. And so therefore, are there still two of the same lengths? It's a rectangle, right? So the length up here and the length down here are going to be the same. This length and this length are still going to be the same. And so therefore, I still have two of them.
So that actually.
So the two sides that equal up to 5.
Okay? So you're calculating numbers. And so if I don't know the numbers, I know that this length increased by 5. I don't know it, but I know that it increased by 5. Do you agree with that?
Yeah.
All right. Do I still have two widths? No matter what. And are those widths different? No. Original widths are the same, so therefore I have 2 times, but how is the width changing? It's being doubled, so that would be 2 times W, right? Now, other than condensing things down and simplifying it, do I have 2 equations?
Yeah.
I needed 2 equations because how many unknowns do I have?
Multiple.
How many multiple?
2.
2. So I need to have the same number of equations to represent the same number of unknowns. And so this one up here is simplified. What form is it in? Standard form. This one down here is not simplified, so let's simplify it down. I'm going to distribute the 2, and I'm going to get 2L plus 10, and this is going to be plus 4W. I combine any like terms. Do I have any like terms I can combine? And so what do I need to do to write the second one in standard form? Subtract the 10. Very good. And so now I have 56 equals 2L plus 4W. Okay, so I have the original equation right there and the new equation right there. Do they have the same variables in them?
Mm-hmm.
They most certainly do. And there's 2 of them, so I can use a system of equations to solve this. You can graph it, you can substitute it, you can eliminate it. Which one does this lend itself to the best? Elimination. I'm going to look at these 2, and I know I got standard form. Okay? And do I have a coefficient of 1? No. Do I have like coefficients with like variables? I wrote this one wrong. You let me write that wrong. It's an L. Okay, I have like coefficients. So therefore, I'm going to use elimination. All right, so to solve this, I'm going to go 2L plus 2W equals 46, and I'm going to go 2L plus 4W equal to 56. So what I'm going to do is I'm going to multiply this by -1, so it'll cancel. And so my top one does not change. It's still 2L plus 2W equals 46, and my bottom one becomes -2L minus 4W equals -56. Most of it by this point, this should be review practice. Up here setting these up, I could take you having some issues. We all in the whole entire school has issues of writing equations from words. But after you have the equation, every one of you should be going, oh, I can solve that now. All right, and so these are going to eliminate. This is going to become 2W. This is going to equal -10. And I know that the W, or the width, of the original is 5, right? So if the width of the original is 5, what's the length? The original equation, or the original perimeter was 46, equal to 2L plus 2 times 5, right? And so therefore, this is really asking you if the perimeter is 46, 2 times what length plus 10 is going to give you 46?
18.
How'd you get that?
Because you took the
Solve
10.
that one.
Yeah, you move the 10 to the other side, divide by 2. Okay, sometimes it helps us when we have, and that's what I like about in implementing some geometry here, is that rectangle is something real. Something real, and so therefore I'm saying, what's the length got to give me this? Those of you that have a little bit more of an abstract or constructional mind, you see this as actual lengths that you're putting together. Okay, and so what it comes out to is L is going to equal 18, and that's what the question asked us.